Good morning, friends. I, Professor Arvind Muddebihar, welcome you to the subject Design of Machine Elements 1. In the previous video, we come across the design of quarter joint, and in today's this video, we are going to study about the knuckle joint. This knuckle joint is used to connect again two rods with a smaller amount of flexibility, or we can say angular moment between the two rods. When such flexibility is required between two rods, we can go with this knuckle joint. Usually the load on the rods to be connected will be subjected to the tensile load. At the end of the one of the rod, an eye is forced, and at the end of the other rod, a fork will be there. The eye and the fork are connected by means of a knuckle pin. The knuckle pin has a head at one end, and at the other end it will be having a collar which is secured to it by a torque pin at the other end. The axis of the rods may be collinear or coplanar and intersecting. Knuckle joints are used in valves and eccentric rods, lever and pump rod joints, etc. So now we'll see about the parts of the knuckle joint, and later we'll study about the design procedure. So in this figure you can see the knuckle joint. Okay, here you can see this is the forked end. Okay, this is the forked end, and this is one end of the rod, and this is the eye end. Okay, and here this we have another rod. uh, we are connecting these two rods with the help of this knuckle joint. And here we have the fork end, and this is the eye end. And you can see this figure, it is available in the data handbook along with its proportion table. Here you can see the F indicates the length of this, which is 1.5 times the diameter of the rod. Similarly, the proportions are given here. C is the diameter of the pinhead, and next we have the thickness of eye, which is given by the F, and here you can see the proportion table how the F is calculated. It is 1.5 times the diameter of the rod. Next we have the thickness of fork end, which is given by B. Okay, again in the proportion table we can see the B is calculated as 0.75 times the diameter of the rod. Okay, so using this proportion table we can calculate the approximate dimension of this knuckle joint. And again we have the set of equations in the data handbook which gives us the exact dimensions which are required for the safe design with the given working conditions. So we'll go through the design procedure now. So first calculating the diameter of the rod, we use equation number 4.19a. The equation is tearing resistance of the rod P is equal to pi by 4 d square into sigma t. Next with the help of another equation, we can find diameter of the rod end. Okay, from the proportion table, S is equal to S1 is equal to 1.2 times the diameter of the rod. Okay, so this equation we can refer in the proportion table, which gives us diameter of the rod end. Next we have design of knuckle pin. Okay, so this is the design of the knuckle pin. This is the knuckle pin which connects the eye end and the fork end. By connecting these two, we connect these rods. The D1, what you can see in the figure, is the diameter of the pin, and C is the diameter of the pin head, and at the bottom we have a collar which fits with this and using a taper pin. So in the design of the knuckle pin, we use equation number 4.20a. Equation: the resistance to shearing of pin P is equal to pi by 2 d1 square into tau. Here we are going to calculate the diameter of the knuckle pin d1. Also we have a diameter of the pin head C is equal to 1.5 times the d. Diameter of the collar is also 1.5 times the d. Thickness of the pin head, which is also collar thickness, is given by capital E, which is d by 2, that is half of the diameter of the rod, so it is 0.5 d. Also diameter of the pin is diameter of the rod. In some calculations we can take this also, and we can select the bigger value of the pin here. So what you have to observe here, we are calculating the diameter of the knuckle pin using this equation, and we are also saying that diameter of the pin is equal to diameter of the rod. Okay, so when we have these two values in the as a d1, we have to select the bigger value of the between them as a diameter of the knuckle pin. So later we will move to the design of the eye. In the design of eye, first we have the thickness of the eye, f is equal to 1.5 d. Okay, and here in the figure you can refer what is here. Okay, see, this is the thickness of the eye. So it is 1.5 d from the proportion table. Next we have the tearing resistance of the section across the eye and along the plane through the pin axis, given by equation number 4.21b, which is P is equal to F into d minus d1 into sigma t, where we are going to calculate the value of capital D from the above equation. This capital D is nothing but the diameter of the eye. And next we have equation number 4.21c, that is the resistance of the rod end to crushing, which is given by P is equal to F into d1 into sigma c. And here we are going to check the compressive stress from the above equation, and it should be less than the permissible compressive stress. So here we are going to find out the value of sigma c, which is compressive stress induced in the joint, and we have to check whether it is less than the permissible stress or not. Next we have design of the fork, and here we have to first we are going to calculate the thickness of the fork end, that is B, using equation number 4.21a. So here we have this equation 4.21a, that is P is equal to 2 into that is 2 times d minus d1 into b into sigma t. Here we are going to find the value of b, which is the thickness of the fork end B. Next we have equation number 4.21d, from which we are going to calculate the permissible stress sigma c, that is compressive stress. Okay, so from equation number 4.21d we have this P is equal to 2b d1 into sigma c, where we are going to find the value of sigma c, and this compressive stress should be less than the permissible compressive stress. Next we have the tearing resistance of the square section, which is given by equation number 4.20b. Okay, and from this above equation we are going to calculate the value of d2 from this equation. Next we have equation number 4.19b, the tearing resistance of two sections across the fork, from which we are going to calculate the value of A from the above equation. So this dimension of A, we can look into the figure. Here you can see this is the thickness of the fork end. So this is the dimension of A what we have calculated. Okay. So this is the design procedure for the knuckle joint. In the next video, we are going to solve the problem on the knuckle joint, that is design of the knuckle joint. So students are requested to comment your USN, that is write your USN in the comment section for the attending purpose, and if you have any queries regarding this video regarding the procedure of the knuckle joint, you are free to ask your queries. Okay, so in the next video we are going to do the design procedure or design for the knuckle joint. Thank you.